Gallup used this as evidence to claim that chimpanzees, at least, have at least the rudiments of self-consciousness and self-awareness. And what's interesting about that, of course, is that chimpanzees are our closest evolutionary relatives. We got, depending on the estimate, 99 or 99.5% of our genes in common with these creatures. Even more interestingly, Gallup and his colleagues tested other primates, tested a couple of varieties of macaques, tested rhesus monkeys, and really got no evidence for mirror self-recognition. In one case, they tested a couple of crab-eating macaques, gave them 250 hours of exposure to the mirror, and still, after the anesthesia procedure, got no evidence of self-recognition. So again, Gallup used this kind of evidence to argue that these chimpanzees had self-awareness. They were able to match their phenomenal experience, that is, their perception of the object in the mirror, with some kind of internal representation of the self. And that implies that A, they have an internal representation of the self, and B, that they recognize it as a representation, that they have, that they understand that their mental states are about something else. Just for the record, this is what happens when you do the same experiment with human infants, okay? And what you see here is mirror self-recognition at relatively low levels in 12-month-old infants, but rising very rapidly by the time these kids are 18, 21 months of age. They're all engaging in mirror self-recognition. So again, here's a behavior that human infants and chimpanzees have in common. Now, there were some critiques of this. I'm not going to spend time on it now. I want to go on to do other things. But Daniel Povinelli, who was investigator, primatologist at Louisiana State University, kind of cleaned up all the details in Gallup's experiment by basically the simple expedient of repeating the Gallup experiment, but looking at chimpanzees' attention to marked and unmarked regions of their face. So do they really look at the mark? Okay, and what you can see here is when you look at either the number of touches of the mark or the number of minutes they spend touching, then these marked animals spend a great deal of time after exposure to the mirror to looking at themselves. Here are the mirror contingent behaviors that Povinelli looks at. Contingent body movements, so the chimpanzee will go in front of the mirror, raise its arm to see the image, raise its arm. Contingent facial movements, smiling or grimacing, and various kinds of self-exploratory behaviors. And here, this is very interesting. Gallup claimed that self-recognition was a characteristic of chimpanzees. Okay, Povinelli, but unfortunately, Gallup had only a relatively small number of chimpanzees available to him. Povinelli had a huge number of chimpanzees available to him for this research, almost 100. And what he found was that yes, chimpanzees do show self-recognition after in the Gallup kind of experiment, but only a minority of chimpanzees do. Here you've got only about 21 out of about 90 the chimpanzees, about 20% or so, showing positive signs of self-recognition behavior. Another 10% or so showing ambiguous signs of self-recognition, but the vast majority of chimpanzees showed no signs of self-recognition at all. Now, what's interesting about this is that human infants aged 18 to 21 months, there are no individual differences. They're up at 100%, okay? But these chimpanzees, they're nowhere near 100%. So yes, some chimpanzees will show self-recognition in this Gallup setup, but not every chimpanzee will. What makes the difference? Well, it turns out older chimpanzees but not too old, they're more likely to show mirror self-recognition. Chimpanzees who are raised in groups, as opposed to those that are raised in isolation, are more likely to show mirror self-recognition. Obviously, animals that have had prior exposure to the mirror. If you just throw a mirror into the cage, the chimps are not going to show mirror exposure at all. Later experiments showed that orangutans have some probability of showing mirror self-recognition. And bonobo apes, which are they're called pygmy chimpanzees sometimes. They're also very closely related to us. And of course, human infants aged somewhere around between 18 and 24 months. If you're a very young chimpanzee or a very old chimpanzee, no mirror self-recognition. If you're raised in isolation, this is quite interesting, I think. If you're a chimpanzee raised in isolation, you're not going to show mirror self-recognition. And of course, if there's no mirror exposure, you don't. Question is, what about gorillas? Penny Peterson, Coco's keeper, has reported anecdotal evidence, anecdotally, that Coco engages in mirror self-recognition. But that was an uncontrolled study, and we just really don't know what goes on with Coco. No other gorilla has shown mirror self-recognition. Baboons don't. Old world monkeys, new world monkeys, they don't. And most non-primates don't. Now, every once in a while, you'll read about an elephant that shows mirror self-recognition. Or you'll read about a dolphin that shows mirror self-recognition. And those studies are pretty interesting, but they share the problem that infected the original Gallup study, which was that we have no idea how representative those individual animals are. Povinelli tested 90 chimpanzees, and he got mirror self-recognition in only a small minority of those chimpanzees. So until we test, a couple of hundred dolphins or a couple of hundred elephants or whatever, we really have no idea how characteristic as a species something like mirror self-recognition is. So again, Patterson has anecdotally reported that Coco engages in mirror self-recognition, but Suarez and Gallup tested four gorillas, gave them 80 hours of exposure, got no evidence of mirror self-recognition, and Ledbetter and Bazin gave two gorillas 400 hours of mirror exposure and still got nothing. So again, Coco is a very, very special gorilla. Coco was raised by humans in the company of humans, treated essentially as a human to the maximum extent possible. And if the anecdote is true, it's not at all clear that Coco's behavior is representative of gorillas as a whole. So here you go. You can kind of map this out in terms of primate evolution. Here's the point. This is evolutionary time. The point at which one species kind of splits off from the others. Back here, when the point where gorillas and humans and chimpanzees had a common ancestor, the gorillas split off, and they just don't seem to have a capacity for self-recognition. Humans and chimpanzees do as well, and orangutans do as well, which means that mirror self-recognition evolved at least twice in evolutionary time. Once for the orangutans, okay, and then another time for chimpanzees and humans. If it evolved twice, maybe it evolved a couple more times. Maybe dolphins have it, maybe elephants have it, but until we get a bigger sample of these animals, we'll really not know about mirror self-recognition in primates. Okay. In this literature, mirror self-recognition is commonly thought of as a behavioral criterion for consciousness. If you recognize yourself in the mirror, we think you've got consciousness. If you don't recognize yourself in a mirror, we think you don't have consciousness. There is another criterion, however, that can come into into play a little bit more recently, and that is what's known as the theory of mind. Those of you who have had a course in developmental psychology, some courses in cognitive psychology, or my course on social cognition, for example, you know something about the theory of mind. It's a very, very, very prominent topic in the study of cognitive development these days. What's not well recognized, in fact, is that the whole notion of a theory of mind has its origins in comparative psychology. Begins with a paper by David Premack and Guy Woodruff from the late 70s, in which they asked whether the chimpanzee has a theory of mind, and they went on to report some experiments they had done with a very unique chimpanzee named Sarah, who played a role in a lot of animal language experiments. Well, what do they mean by a theory of mind? What we mean by a theory of mind is that people develop some understanding of how their minds work. First, people develop an understanding that our mental states are not just experiences, but they are representations of something else. That when we see something or hear something, that's not a direct reflection of reality, but rather is something, a percept or an experience that we're generating for ourselves, and which may or may not be an accurate representation of what's going on in the world outside. So the first element of theory of mind is that, we don't just have mental states, but that these mental states are representations of other things. The second element of a theory of mind is that other people have these mental states, these representational states, these beliefs and thoughts and feelings and all of that. These beliefs may be true or false as well, and they may be different from our own. So this critical part of the theory of mind is the idea that my thoughts may not be the same as somebody else's thoughts. And to have that insight means that you recognize your thoughts as your own and as a product of your own mind. That's David Premack. That's Sarah, the chimpanzee, and that's John Flavel at Stanford, who is really responsible for bringing this notion of the theory of mind into human adult psychology. The theory of mind is traditionally assessed by what's known as the false belief task. It's a really quite interesting task, illustrated here, where you've got three characters in the experiment. You've got a child who's the subject, you've got an experimenter, and you've got this prop, which is a puppet. And in phase one of the experiment, what will happen is that the experimenter will, using the puppet, will hide some object, like a ball, inside some container, like an oatmeal container. Always use oatmeal containers in these experiments. So the puppet does this, okay, hides the ball in the oatmeal container, and then the puppet is put away in a cupboard. Then the experimenter and the child together take the ball out of the oatmeal container and put it in another container, like a box. And then the experimenter goes and gets the puppet out of the cupboard and says to the child, which you can do to a young child, this puppet would like to play with the ball. It wants to go get the ball. Where's the puppet going to go?